If you were to pick a raw olive off of an olive tree and bite into it, what you'll find is that it's actually extremely bitter and borderline inedible. Now, the thing is, if you take that olive and you actually ferment it, it actually becomes palatable and it tastes like the olives that we get at the store. Additionally, it means that the olives don't need to be refrigerated. So the question is, what's going on here? And the answer is bacteria, or at least microorganisms. So today I want to dive into fermentation and talk about all the things that make the foods that we love so delicious. But first, hi, welcome to the Flavor Lab. My name's Logan, and this is the first episode of the Flavor Lab podcast. Now, this podcast was kind of born for several different reasons. One, and primarily the main reason, is I want to get content to you all a lot sooner. The problem is that videos, they can take a lot of work. It can take me months, honestly, since I'm just one person kind of working on stuff. This podcast allows me to have an opportunity to just kind of sit in front of a microphone and do some light editing and get this out to you guys a little bit sooner than maybe otherwise. Secondly, I've been doing a lot of research recently for a book that I'm working on. It should be coming out soon, but I've basically learned a lot of cool stuff, and I just want to share that with somebody. So a lot of the stuff that wasn't able to fit into the book is just going to spill over into this podcast. Now, a couple of other things. One, you may hear my cat Liam participating in this. He decided that he wanted to join this podcast as well. So every once in a while, he comes in and interrupts me and headbutts the microphone or something like that. So sorry if you hear that. And then lastly, if you're watching this on YouTube, you might be wondering, what the heck am I looking at right now? Well, this footage is actually from kind of a failed video. I was trying to measure how much caffeine is actually in coffee, but it didn't really turn out to work out the way that I wanted it to. So I have all this beautiful footage, or I think it looks pretty cool. And I thought it might be fun to kind of put this to the background of the podcast, so you have something to look at if you want to. I mean, I may end up taking up this video again at some point, but for right now, this is definitely probably the only use of it. So you're going to see me kind of measuring out caffeine and putting it into a spectrophotometer during this podcast. However, it has nothing to do at all with fermentation, other than the fact that coffee is fermented. Okay, so let's go ahead and jump into fermented foods, and I want to start by talking about what are fermented foods. Now, we all kind of have maybe some inherent sense that certain types of foods are fermented. For example, maybe alcohol, things like yogurt or cheese, soy sauce. These are all kind of commonly known to be fermented. But some things are a little bit more interesting, and I mean, things that you may not associate with fermentation, like sake, vanilla, or chocolate. These things are also fermented. This goes to show that there's just a lot of different types of things that we actually enjoy that are fermented. Not just that, there's a lot of fermentation from all around the world. It's not just the Western style of things like sauerkraut and yogurt that are fermented, but really every culture has independently invented some form of fermented food. And I say the word invented because it really is a human invention. There's utility behind it. Not only does it make our food taste good, but also it acts as a really powerful way to preserve food, something that was a lot more difficult before refrigeration. You know, if you can imagine in situations where you have a rainy season or it's a cold winter, you may not be able to have access to certain types of crops. So having something that's fermented that can actually last a long time is pretty darn important. And that's one of the reasons why humans invented it. Additionally, it can give us access to things that we may not have been able to have access to beforehand. It can take basically food that has vitamins that are locked up and basically our body can't process and turns them into things that our body can process. And so let's talk about what actually is fermentation and what does that word even mean. Now, fermentation, kind of in a normal, narrow context, is associated with yeast and essentially turning sugar into carbon dioxide and or lactic acid and or ethanol, depending on the situation where the yeast is actually being fermented. But that's a really narrow definition. There's actually a lot of different types of fermentation that actually don't involve yeast at all. Perhaps the most common of this that you might be associated with is yogurt. That's not actually fermented with yeast, but something called Lactobacillus. And we'll talk a little bit more about Lactobacillus a little bit later. Additionally, there's other types of things like Koji, which is a type of mold, actually, which is a powerful thing for actually being able to turn rice into something that can be fermented. So it's not necessarily just yeast. It can be a lot of different things that actually contribute to fermenting something. So what is actually going on when we ferment something? Well, let's first take a step back and think about the microbiome for a second, or like basically where bacteria, their realm. So on this scale, literally everything is fighting with each other. And they're all, just like at the macro scale, everything in the micro world is fighting to stay alive. And it's doing this by taking in food, converting that to energy by processing it, and then reproducing, and then eventually dying. And essentially, this is what it looks like down there. But there are limited resources. If I have a sugary liquid, there's only so much sugar that can be consumed in this liquid. So, or all of the microscopic things at the scale are fighting to be able to get access to that. So there's kind of competition going on. What we do when we actually are doing fermentation is this is kind of human intervention where we kind of weigh in on one side of these, microorganisms, and we say we want these ones to succeed and we want other ones not to. Now, thing is, this can be done kind of by accident. I mean, there's a lot of conditions where humans can kind of let this kind of happen, kind of like farming. If a plant will grow naturally, but there's things that humans can do to make something like an actual farm, where they actually kind of selectively say, I want this one to succeed. And essentially, that's what people are doing when they're fermenting at a micro scale. You're essentially setting up the conditions so that the bacteria or microorganism that you want succeed. And so let's take the example of wine. Okay, so we have a sugary liquid, and that sugary liquid wants to be consumed by all sorts of things. Some of those microorganisms may be kind of harmful to us, or at least the byproducts of them might be harmful to us. And some of them are what we want, for example, yeast. And so let's start with just kind of talking about where do these things actually come from. And the answer is the air. Right now, floating in the air are a bunch of different types of spores of everything. And it could be yeast, it could be something harmful, it could be, mold, it could be whatever. This is all just floating in the air all the time. And then you have basically, it's going to land on some liquid or some the surface of a fruit or something like this. And it's going to start reproducing and kind of in hopes that it's going to be able to find food. So yeast will take in that sugar and the grape juice essentially and turn that into alcohol and other stuff that tastes delicious. And that's what we want. So what we can do is we can actually create an environment by adding in or inoculating this sugary liquid with a bigger starter amount of yeast to be able to kind of let the yeast kind of get a head start on all the different other types of bacteria that are in there. Additionally, we can do other things to intervene. So for example, we could sterilize the grape juice basically by boiling it, and this will reduce the amount of other types of microorganisms that are in the sugary liquid to begin with, giving our yeast even more of a head start. Now, once it has this head start, what does it do? Well, actually, yeast is going to create a byproduct that's going to kill all of its competition, and that's namely ethanol or alcohol, as it's kind of more commonly known. Other types of bacteria don't like alcohol. I mean, that's the reason why alcohol is an antiseptic or why you can use it to sterilize stuff. It just kind of doesn't work with other bacteria. It just doesn't work with other bacteria. It kind of kills them. So the byproduct of yeast is that it creates this ethanol, and then that kills other stuff. And that basically means that we're going to have the more yeast that there is, the more the other bacteria are going to get in contact with this alcohol and die off. Now, obviously, the yeast itself is capable of withstanding the alcohol, so they survive. And really, you end up with a selective, at the end, you have the sugary liquid that anybody can consume. And in the end, you create this kind of weird toxic environment to other bacteria that only really yeast can survive in. And that's essentially what we're doing when we're fermenting something. A similar process happens with Lactobacillus. Essentially, Lactobacillus is very tolerant to low pH, or essentially acidic environments. So when Lactobacillus basically gets food, it processes that and creates lactic acid. That lactic acid, for example, is what gives yogurt its distinct tangy flavor. And also, it really is kind of the sour flavor, one of the sour flavors that you get in naturally fermented foods. For example, in terms of sauerkraut, if you've had a real sauerkraut in German literally means sour kraut. I can't remember what kraut means. It's not cabbage, but sour is acid. And it's because it's sour, it's an acid, and that comes from the lactobacillus itself. Additionally, I want to make one more note here. So I'm going to be broadly talking about different groups of types of fermentation. So some of the main ones are obviously yeast. Another one is these lactobacillus, which are basically which basically they create lactic acid. I'm also going to be talking a little bit about acetic acid or acetobacteria. And all of these are really just the specific examples. So each type of bacteria will give you a slightly different product. People who brew beer or are familiar with beer may be aware of this already. So for example, if you've had one of these sour beers that are kind of more common these days, that's because of the type of yeast that they're using, among other things. But one of the main reasons is because they're using a type of yeast that kind of creates that sour flavor. Additionally, Hefeweizens, the yeast that you use in a Hefeweizen beer, kind of gives off the same chemical flavor compounds that give bananas their flavor. And so that's where that's where Hefeweizen get their kind of banana-y flavor from. Different yeasts will basically give you different types of beer. I mean, obviously, it's important what, ingredients you put in there as well, but the yeast can make a difference in and of itself. This is also, for example, the case with sourdough bread. Everybody's kind of familiar with the idea of, the fact that San Francisco has supposedly a unique type of a sourdough. I can't taste it, but I know it's a thing. And that's because of the fact that the Bay Area itself has kind of its own culture, our own species of yeast that's in the air, and that basically is responsible for the sourdough that comes from San Francisco. Now, personally, when I've gone to San Francisco, the bread I've had has been kind of mid, and I think it's mostly just a lot of sugar. I'm talking from the main bread place, but this is a whole nother side topic. Maybe I'll talk about bread another time. If you want that, please let me know in the comments, or let me know what else you want me to talk about. Okay, now back to this. Okay, so we've talked now about fermentation, and we've talked about kind of a little bit about the byproducts. But I want to dig a little bit deeper into the byproducts, because this is actually really interesting, right? So it actually is what's responsible for making our food spoil. So when we have fermentation that goes well, like we want, essentially we can have something like milk, and then it's basically fermented, and then we get yogurt at the end. Well, as I said, it's not just, lactobacillus or yeast or whatever that has access to these, to this food. It could literally be anything. And this is actually what causes food spoilage. There was Liam jumping up there. Food spoilage essentially is when one of these other bacteria that we don't want take over the environment. Essentially, the contested battleground gets lost and the battlefield is basically given up to something else. And sometimes that can make us really sick. Now, in general, the bacteria itself is completely not harmless, but it's not really the problem. Usually the problem actually is the byproducts of these other bacteria. So just in the same way that alcohol is a byproduct of yeast fermentation, other things can make byproducts that are extremely toxic to us, and they can't be killed by cooking. So if you cook something, if I had beer that was, that had yeast in it, was fermenting, if I cook that beer, the yeast will die, but the alcohol will still remain in the beer. Similarly, I can have something like the spores of what is responsible for botulism. If they get in contact and basically they start creating this toxin, which is essentially botulism, if I cook that material, if I cook the beans or whatever that it was growing in, it will kill the actual spores of it will kill what's responsible for creating the botulism, but it won't kill the toxin itself. And that's why it's so dangerous. Additionally, the same thing goes with mold. It's not that the mold on your bread is necessarily the problem. Maybe toasting it could kill the mold itself. It's the byproducts that they can create. Some of them are extremely harmful just because they do weird stuff to our body. And that's not really their fault, but it's just not great for us. So that's why so essentially when you think about something spoiling, that's what's happening. It's other bacteria have taken over and kind of colonized the food and just basically taken it over. And the process of fermentation is just putting our thumb on the scale and say, I want this one to succeed. And that's typically why the foods that are fermented tend to last longer, because they're in an environment where they kind of kill off all of their competition, but for us, our body can process it. And so we've talked about lactobacillus, we've talked about alcohol. Another one of these processes is acetic acid. So not lactic acid, but acetic acid. And acetic acid is the primary souring agent in vinegar. And so I initially thought that this was just from the one bacteria called Acetobacter, which is one of the main ones that creates vinegar. But also it's actually from a group of different types of bacteria, which are all contributing to creating acetic acid. It's kind of a whole broad category. It's like saying oranges. There's a lot of different types of oranges, but it also describes the whole family. So Acetobacteria basically are responsible for taking things. They can even take ethanol and break that down into vinegar. So let's start from the beginning. So we have our grape juice. It's got sugar in it. Everything wants at it because sugar's a really good source of energy, a really easy processable source of energy. But we put then our yeast in there, and we let the yeast basically start fermenting it. It turns it into wine. So we have alcohol, we have some residual sugar left over, and we have some dead yeast cells, which basically at the bottom, once the alcohol gets too high, it will also kill the yeast at some point too. So we have some yeast, alcohol, sugar, and that's all there. Well, what happens is if we have let this stay exposed to air, what can actually happen is that the acetobacteria, which are floating in the air, can land on this wine and actually turn it that ethanol into acetic acid. And it's pretty magical. And then once you have the acetic acid, you can use that to take a vegetable. And if you put a cucumber, for example, in your acetic acid, you get a pickle. So, it's a really, not only these byproducts that these bacteria are creating are just extremely useful. Obviously, ethanol is great, alcohol is awesome, but there's vinegar itself is great, and so is lactic acid. I don't know of stuff that's kind of pickled in lactic acid, but I'm sure it exists. And then, so those are kind of the three main ones that create the food that we associate with. I want to talk about two more that I was a little bit less familiar with, but I think are kind of interesting. One being Koji. And so Koji is basically a type of mold, and it's basically able to break the starches down in rice and soybeans into more simple sugars, which can then be processed by other bacteria. And so in the case of sake, if I were to just take rice and I were to soak it in water and I put yeast in there, it wouldn't do anything because the yeast can't break down the starch in the rice into sugar. But the Koji mold, that's exactly what it does. It takes the starch of the rice, it breaks it down into kind of a simpler sugar. Then the yeast that's in the air can kind of interact with that and turn those simple sugars into alcohol. And that's where we get sake from. It's possible that you don't just get one thing, you don't get just yeast, but you get a bunch of different types of things that kind of all work together collectively. And they kind of all fight together and create kind of an alliance to say, hey, all this other stuff, we're going to keep you out. The most common example that I'm familiar with is in terms of a SCOBY, or basically if you've ever had kombucha, it creates this, if you ever made kombucha, it's really weird. If you haven't, let me explain to you. It's bizarre. So basically, if you have kombucha, you have tea and sugar, and then you have this weird, like jelly, like placenta looking thing that's kind of floating on the top. It's gross. It looks gross. It's not gross, but it kind of looks gross. It looks definitely super weird. And it's almost like a mushroom or something like that. And it's just kind of floating on the top, like a giant, really thick skin on top of this kombucha. Well, what this actually turns out to be is it's called a SCOBY, which stands for a symbiotic culture of bacteria and yeast. And basically what it is in the name. It's the yeast and bacteria basically have formed an alliance, and they've created this structure called a SCOBY. And they're basically working together to be able to turn the tea and sugar into all sorts of crazy tastes and chemicals, or not chemicals, sorry. Well, they are chemicals, but a lot of different things that basically make kombucha taste like kombucha. And so in there, you're going to have acetobacteria. The actual structure of it is made of cellulose. So basically it creates another bacteria's job is to just literally make the scaffolding, or essentially the jelliness that you are touching when you touch a SCOBY. One bacteria's job is just to do that. Another bacteria is doing this. And essentially all of them are working together to be able to create something. This is actually the case really for most fermentation. When we think about even things like beer brewing or winemaking, we are isolating one, but there's actually a bunch of different things all working together in tandem. And sometimes it's so complicated and the microorganisms used are so unique that we don't even bother trying to describe what is going on. In the case, for example, of chocolate, apparently when you have a raw cocoa pod, which is that white bean if you've ever seen my chocolate video, and then you go to the brownish, weird looking decomposing thing that it basically was what makes chocolate, the stuff that's in there is doing all sorts of crazy things like breaking pectins down and all sorts of changing the flavor. And like the same with the olives that I mentioned at the beginning of this episode, all of these are working together to just break down certain stuff that's, and turning it into stuff that we can actually consume. And lastly, on this topic, I want to say that our body is actually is utilizing this process in and of itself. So fermentation is kind of a human invention externally, but this is actually going on inside of us right now. And I know there's been a lot of attention recently about the microbiome, but basically we have a colony of all sorts of microorganisms in our gut, which essentially are doing this process of breaking down stuff into simpler sugars, which our body can process and actually absorb and turn into energy. And they're doing them for us. So we give them a ride, and basically they hang out in our gut. And when I eat an apple, maybe there's some fiber or something that is insoluble that our bodies naturally can't process. But a bacteria that's there will be able to ferment it and turn it into something that I can process. Just like the same as the rice and the Koji mold that I talked about earlier. So with that being said, that's kind of a little bit of a foray, like the little foray into fermentation. I just want this to be a first episode, just kind of briefly talking about this stuff. If you guys want me to dig into a specific type of fermentation later, I can. I will probably do a video on alcohol at some point, and I'll also probably do a video on bread at some point. But if there's another topic that you want me to cover, let me know. I'm all ears. This is totally an experiment, like everything else on my channel. So if you made it this far, I appreciate you. You're awesome. If you're new to the channel, please consider subscribing, because that really, it gives me a little bit of an ego boost, and that's what keeps this channel going. And lastly, if you want to help the channel actually stay alive and financially support the channel, I have a Patreon that's going to be linked down below. Basically, that really helps me be able to keep the Flavor Lab space where I'm currently filming. And yeah, and that's really that's another reason why this channel keeps going. So I'm going to try to start giving some rewards. So for example, maybe you'll get early access as well as your names and stuff if you support me on Patreon. But with that being said, that's basically it for this week. And I hope to come back with another podcast and hopefully a video, which I've been working on very soon. All right, I'll talk to you all later. All right,